Hello, today we'll be going over AtCoder Beginner Contest 168, Problem C, which is titled colon. So the problem statement is that you're given four integers, a, b, h, and m. What a and b are the side lengths of the hour and minute hand. H is basically how many hours have passed since 0 o'clock. So we can write this as t of h, and m is the amount of time in minutes that have passed since 0 o'clock. What we're asked to find is, given the clock and given the two side lengths, let's say this is the hour hand, and we can draw the minute hand in red over here. So these are the lengths and the time is given. We want to find the third side length that can complete this into a triangle. So in order to find this third side length, what we can do is that we can label this as A, B, and C, the three lengths of our triangle. Now what we want to do from here is that we want to use some math by applying the law of cosines on this triangle. So given the time, we can actually find this angle here. We can note this as C prime for right now. And what the law of cosine states is that C squared, which is the side length which we want to find, C squared is equal to A squared plus B squared minus 2AB times the cosine of C prime in this example, where C prime is that angle measurement between lengths A and B. Now let's go over how we're going to calculate the amount of degrees in the angle. So you can see that a perfect clock is a total of 360 degrees because it is a round circle. Now in order to calculate the amount of degrees presented by the hour hand, we can see that in the circle we see 12 bigger ticks, each representing 1 hour in the entire clock. So we can take our total amount of degrees divided by the 12 bigger ticks, and we can see that there are 30 degrees in each hour. Now let's look at the little ticks. So in each hour, we can see that there are 5 little ticks that appear. For example, at 12 o'clock, 12:15, 12:30, 12:45, and then finally 1 o'clock. So you see that there are 5 smaller ticks. So we can take our 360 degrees divided by the amount of bigger ticks times the amount of smaller ticks. This would be the total amount of smaller ticks. And you can see that we get 360 degrees over 60, which is 6 degrees for each minute. But there's one thing which you need to take into consideration. If you look at an example of the clock at 3:30, we see that the hour hand is in between the 3 and the 4. However, so in order to account for this, we need to look at how many more degrees we need to add to the hour hand. So what we can do is that we can label two variables, mdeg and hdeg. So what these are is basically the degrees of the hour hand which we have right now. And because we have 30 degrees in each hour, it will just be 30 times h. And mdeg similarly, 6 times m. So now in order to account for this 3:30, we can look specifically at the example. The hour hand is 3:30. So what we have is the hour, 3 times 30, which is equal to 90, plus 1 hour. 3:30 means that in each hour there are 30 degrees. So it's past that 30 degrees, it'll be plus 15 degrees. And if we look at the minute hand is just 6 times the amount of minutes, which is 30, which is equal to 180. So now we know that the extra value we need to add to the hour hand is dependent on the minute hands. So looking at this, we can devise a formula that all we need to do is take the amount of minutes degrees, divide that by 12 over here, and then we can actually get the amount of extra we need to add to the hour hand. So we can write h degree as 30 times h plus mdeg over 12. And this is how we are going to calculate the degrees of the angle of, in our diagram previously, C prime. From here, what we can do is that we can calculate the total amount of degrees, the absolute value, between hdeg minus mdeg. And the reason for the absolute value is given the clock 3:30, we can see that the minute hand is greater than the hour hand. But in reality, we want the degree that is between them. So you take the absolute value in case mdeg is greater than hdeg. One problem which we'll face when converting everything by doing the cosine function is that we currently have everything calculated in degrees over here. However, taking the cosine function, especially in C++, will convert everything to radians. Radians is another unit of measurement. So in a circle, this is equal to 360 degrees, as we've been using this entire time. But it is also equal to 2 pi radians. So if we take the cosine of deg, we're going to get this in radians. But we want to convert this to degrees. So in order to do this, we can see that in 180 degrees, if we take this information, 180 degrees is equal to 1 pi radian. This means that 1 degree, if we divide everything by 180, is equal to pi over 180 degrees radians. Therefore, in order to convert everything into degrees, we can just take our cosine here, and then we can just multiply by pi over 180. And then we can set this equal to some variable. We can call this cos deg, the official value of the cosine of the degrees which we want. And then we can, after this, we can just simply apply everything and plug it into our formula and then get the answer afterwards. One small thing which you might want to keep in mind is that in the languages, it may not print up to 20 digits after the decimal point. Therefore, specifically in C++, you can use cout fixed show point. And then after this, you can print out cout set precision. And then 20. And then after this, you can print out your answer. Now let's quickly go over what this does. So basically, what this does is whatever value which you input into here is basically how many digits after the decimal point you're going to print out. And since in the problem it states that the error can only be up to 10 to the power negative 9, we can ensure that we have to print out more than 9 digits after the decimal point. So to keep everything safe, we can just print out a total of 20 digits after the decimal point. And this is a very simple way where you can print this out. Now let's move on to how we're going to code this. One thing to do before we start is we have to hashtag include CMath, and we have to hashtag include IOMAN IP. And we also have to define pi. After defining everything, we can begin coding our solution. So we're going to start off with our 4 integers, which we can write as long doubles. After inputting them, we want to start calculating the degrees. In order to do this, we can use the 2 formulas which we wrote beforehand. We can have a long double hdeg equal to h times 30, and long double mdeg equal to m times 6. But remember, at the end we have to do hdeg plus equals mdeg over 12. Then at the end we can have our long double final amount of degrees, so you can just write this as deg, equal to the absolute value of hdeg minus mdeg. After this, we want to start applying the law of cosines. In order to apply this, we can create a long double. We can title it cos deg, and we can set this equal to the cosine of deg times pi over 180. Then remember, in our formula we had a squared plus b squared minus 2ab times the cosine of c. We can create 2 long doubles, a square equal to a times a, and another one b squared equal to b times b. Now we just have to plug everything into our equation. Long double C is equal to square root of a squared plus b squared minus 2 times a times b times cos dag. And this is our answer, so now we just have to do the thing which I mentioned previously. C out, fixed, show point, step precision, and then we set this value equal to 20, because we're going to print out 20 numbers after the decimal point. And then we're going to see out C and line and return 0. And then submitting gives us a correct answer.